Welcome to Equations of Best Fit. So for this, we are going to be doing linear versus quadratic models. So a linear equation. Linear equations are, we did these earlier this year, you have y equals mx plus b. That's a straight line. That's the general equation for a straight line. To type it in Desmos, though, we can't just type in y equals mx plus b. So when we're finding the line of best fit, or the equation of best fit, we are going to type in y sub 1, and I'll show you how to do this. Little squiggly line, not the equals, mx to the sub 1 plus b. So that's what we'll type into Desmos when time comes. Now for a quadratic, this equation, to get a general model of an equation like this, is going to be y equals ax squared plus bx plus c. Now, that might be a little confusing or not understand at all, but when we type it into Desmos, we're going to be typing in y sub 1 equals ax sub 1 squared plus bx sub 1 plus c. So in Desmos, the Desmos is going to help us out a ton. We're going to be typing in both the equations, and then we're going to use what data we get from it. So the Desmos is going to be awesome. It's going to give us a lot of information, and I'll work through it with you how to get the information out what we need. So first thing, we're going to be determining. We're going to be getting a table of values, and we got to determine, is a linear equation the best that's going to represent? Would it be like a straight line that would represent the values if we plotted them, or would it be more like a quadratic, the points? I mean, could you imagine, like, if you throw a ball up in the air and it comes down, that's going up and down, that's a quadratic, that's going up and down. Something, I mean, there's many different quadratics and linear models. So we'll work through it as we get there. So these are the steps, 1, 2, 3, 4, 5, and I'll work through them as we get there. We have to use Desmos on this. It's the only way we're going to be able to work these out. It's the only way to understand which one is actually better, linear versus quadratic. So let's take a look. So we're going to go to the Desmos, and I'm actually going to erase what I got in here. We're going to go to Desmos, we're going to hit the plus sign, and then you got table. And then in the table, we are going to, I'm going to type in this first table. So the T is going to be our X, and the S is going to be our Y. So let's go back to Desmos. And so the X sub 1 is going to be 115. I hit the enter. 140, enter. 76, enter. 168, enter. 110, enter. 92, enter. I'm going to click on the Y. 1,122, 1,390, 788, 1,564, 1,081, and 924. All right, now those are in. In line 2 and line 3, this is where we're going to enter those equations that I wrote. So we touch the Y button, then 1, and that puts it as a sub 1. Now we can't use equals here. We're going to go to ABC and go down on the bottom row. The second from the right is a little squiggly. And then we have M, X, and we're going to do a 1 again for sub 1. Then plus B. You're going to see all these numbers, and I'll let you know what those numbers mean in a little bit. I'm going to go to line number 3, and I'm going to do the same thing, but with the quadratic. So it's y equals, and you can type the y in if I can find it, y sub 1 not equals, little squiggly. What that does is it tells the calculator to find the line of best fit. So sub 1 squared plus bx sub 1 plus c. All right. So now we have our r values for both of them, or r squareds. And we're going to go back to the original paper and what our notes are here. So looking at the r squared value. So you see, look at the r squared value now. And whichever r squared value, the closest to 1 is the best fit. So we got to really be careful with our numbers. So when we're looking at our numbers, can I highlight here? No, I can't. So when we're looking at our numbers, the linear is 0.9936, the r squared, and the quadratic, the second one in red here, is 0.9949. 0.9949 is bigger than 0.9936, so that means the quadratic is a better model. So the quadratic is a better model. So I'm going to go back to my paper, and I'm just going to write quadratic just so I remember that. The quadratic is a better model. And the equation, so we're going to have to pull the equation off. The equation is going to come from down below. You see the A, B, and C. I'm going to write this off to the side. The A equals negative 0.01. I'm going to round it to 0.01. The B equals 11.33. And the C equals negative 21.69, or we'll go 0.7. So let's write that down. So I have A equals negative 0.01. The B was 11.33, and the C is negative 21.7. Now that's not good enough. That's not an equation. So we need to put it in the equation. We're going to go back to the y equals mx plus b, or not y equals mx plus ax squared plus bx plus c. And we're going to substitute a, b, and c in. So the a, b, and c, we have y equals negative 0.01 x squared plus b, 11.33 x plus, actually just not a plus, it's a minus, because it's a negative, so plus and negative is the same thing as in subtract, 21.7. And there is our equation that would best model these points. If you plotted them, it would go through those, the closest to those points of all of them. Let's do one more, and then I think that'll be good. Otherwise this video is going to take way too long. So let's do the coin is thrown off the top of Statue of Liberty, which is 305 feet from the ground. So I'm going to go to my table. I'm going to erase it. Actually, I didn't have to erase it. Oh my goodness. I said erase the table. Can I go back? Oh, I can. Sweet. So I got to erase the table though. And I'm going to type in the third line now. I'm going to type in the table. And our numbers are 0, 1, 2, 3, 4. Oh, that's easy. Sweet. No, not 5. Not 5. All right, going back. We got 305 for at its starting point. That's times 0. That's before, like right when it before it started. Coin must have got thrown up in the air because it's higher. 397. 395, 361. Okay, so now let's look at what we got going up to. Oh, what's my problem? I got a problem here. Oh, I got it. So if you look at my table up top, it says x sub 3 and y sub 3. Oh, and look at my equations. They just have sub 1s. We need to change those to 3. We do that, then it'll know to pull from the third table, the third line. Oh boy. Yep, we gotta change all those little 1s to 3s. That's all right, we can do it. We got this. So now I am seeing the R squared values. And now let's look. We got linear is, the R squared is 0.3535. Not very close to 1. But look at the second one. The R squared value is 1. That tells you it is a quadratic. And hey, take a look at the graph over here on the right. The red line is a quadratic. That's U-shaped. It is perfect. It's going through those points. Look at the blue line. It's not even close to being going through those lines. So that's why the R value is 1. It's going actually right through all the points perfectly. So I am going to write down the A, B, and C. So negative 16, 78, and 305. And I'm going to write that down on our test here. So we got y equals negative 16 x squared plus 78x plus 305. And that is the equation of best fit. Come to class with other questions. I know we didn't do a linear one, but we'll do it in class. Thank you.